We are officially just a couple of days away from the first Starship flight of the year, and because of that, a lot of details have started to come out. Today, we're going to look at how SpaceX has been preparing the vehicle, the brand new flight path for the mission, and some of the latest testing happening behind the scenes. And later in the video, I'll also talk about an important new update regarding NASA's next Artemis moon mission, so make sure to stick around until the end to find out. Okay, so first off, SpaceX just completed another full-duration, full-thrust, 33-engine static fire with Super Heavy V3. From everything we've seen so far, the test appeared to go well, and SpaceX described it pretty positively too, making it another major step towards Starship Flight 12. Some observers even think the outer ring of 10 engines may have gimbaled outward about halfway through the test, but we'll have to wait for official confirmation from SpaceX to know for sure. Anyway, this latest test also explains why the launch schedule has slipped a little recently. Flight 12 was originally aiming for May 12, 2026, but now the earliest possible launch date looks to be May 15th, with backup opportunities available each day through May 21st. This was actually Booster 19's third static fire test. The reason they needed another one goes back to the previous attempt, which was also a full 33-engine firing. That test ended early at around T plus 1.88 seconds because the pad triggered an automatic abort. Based on what we know, sensor readings on one of the ramp manifolds showed low pressure, but there's a good chance it was just a false alarm caused by the insane vibrations and extreme conditions during the test. Even with the abort, the test was still considered useful. Lighting all 33 engines at once and shutting them down safely without major damage is already a huge achievement. These tests are exactly how SpaceX finds and fixes problems before an actual launch. Another issue SpaceX has been dealing with involves the deluge system. During a recent test, the company ran several systems simultaneously to simulate real launch conditions. At some point, something went wrong with one of the gas generator systems, or at least a system related to it. There appeared to be some kind of explosion or major failure that damaged part of the structure and even blew sections off the enclosure roof. We still don't know the full story yet, but it definitely doesn't look like a minor problem. So honestly, it makes sense that SpaceX is taking a bit more time to work through everything before sending Starship Flight 12 off the pad. Even though it's now been more than half a year since the last Starship flight, a lot of people actually think SpaceX is making the right call by slowing things down a bit. With all the recent issues, especially the problems involving the water deluge system, which is incredibly important for protecting the launch pad and making rapid reusability possible long-term, it makes sense to focus on more testing first. At the end of the day, it's far better to delay a launch than risk seriously damaging the pad. After all, SpaceX can build new rockets surprisingly fast, but right now they only have one fully operational orbital launch pad. If that pad suffers major damage, it could delay the entire program for a very long time. The next major step is likely one final full rehearsal, also known as a wet dress rehearsal, where the entire rocket is fully fueled but doesn't actually launch. And honestly, by the time you're watching this video, SpaceX may have already completed that test. That's just how fast the company moves. There are definitely still a lot of tests needed before this new version of Starship flies for the first time. In fact, if something doesn't look right just before liftoff, the system can automatically trigger an abort. So in a way, the actual launch attempt itself becomes the final test. They ignite the engines, check that everything is performing correctly, and only continue if all systems stay within limits. If not, the rocket shuts down immediately. Every extra test helps SpaceX better understand the vehicle and lowers the chances of something going seriously wrong during launch day. We finally have the flight trajectory for Starship Flight 12. Since this is a new version of Starship, it's also coming with a new trajectory, and even a different kind of launch window happening in the afternoon. The launch window runs from 22:30 to 0:43 UTC, which translates to 17:30 to 19:43 local time at Starbase. This time, instead of flying through the usual corridor between Florida and Cuba, Starship Flight 12 looks like it'll take a more inclined path. It basically threads its way between Mexico's Yucatan Peninsula and Cuba, then passes near places like the Cayman Islands, Jamaica, Haiti, and the Dominican Republic. Even with this change, the splashdown point is still planned for the Indian Ocean. The flight path continues across airspace near Madagascar, Mauritius, and Australia before re-entry. The biggest change here is that narrower, more southern trajectory. The rocket still launches eastward, but at a steeper angle than before. It avoids the old Florida-Cuba corridor, which is likely better from a safety standpoint, especially for air traffic and populated areas. After that, re-entry happens over the Indian Ocean, with splashdown off the coast of Australia, pretty similar to previous flights. Overall, this new trajectory helps SpaceX test higher inclination flight paths, which could be useful for future missions. It also gives them more data for improving reusability and working toward those tower catches. It's hard to deny that this is one of the most exciting and important Starship launches in quite a while. This will be the first flight since October 2025, but more importantly, it marks the start of the Block 3, or Version 3, V3, era for Starship. And this isn't just a small upgrade. V3 represents a pretty big leap in hardware and overall capability, bringing Starship closer to actually being ready for real missions. We're talking about things like NASA's Artemis lunar landings, in-orbit refueling, and eventually even missions to Mars. So while Flight 12 itself is still a suborbital test, similar to previous launches, it plays a key role in moving toward full orbital operations. That includes launching next-generation Starlink satellites and supporting future Artemis missions. In a lot of ways, this flight is the first real look at a more production-like version of Starship. That's what makes it so exciting. There's a lot of new tech involved, and with that comes a lot of unknowns. But at the same time, it's important because every step here helps push SpaceX closer to rapid reusability, higher flight rates, and eventually, crewed deep space missions. That said, not everyone is feeling the excitement. As SpaceX prepares for this first V3 flight, the company is also dealing with a new legal challenge from local residents, who claim that Starship launches have been damaging their homes. The environmental impact of launches from Starbase, located along the Gulf Coast of Texas near the Mexican border, has been debated for years now. SpaceX has received federal approval to conduct these launches, but concerns from nearby communities and environmental groups have never really gone away. Now, those concerns have turned into legal action. On April 30th, a lawsuit was filed in a U.S. district court in southern Texas by dozens of residents. They claim that previous Starship launches have caused damage to their properties. The case includes around 80 people from nearby areas like Port Isabel, South Padre Island, Laguna Vista, and Laguna Heights. Altogether, they represent more than 50 homes located within about 24 kilometers of the Starbase launch site. According to the lawsuit, every one of the 11 Starship test flights since 2023 has resulted in some form of damage. A big part of the complaint focuses on the sheer intensity of the launches, especially the sonic booms. The plaintiffs describe them as extremely powerful, so much so that the effects are difficult to fully put into words. They argue that each Starship launch can have a combined impact comparable to multiple launches of NASA's most powerful rockets, along with several Falcon 9 flights. In their view, these are some of the most energetic and acoustically intense rocket launches ever conducted. Now, as promised, let's end this on Artemis news. Recently, a NASA Request for Information, RFI, about adding a new communications system to the Artemis III mission was revealed. This is basically asking the space industry, does anyone already have technology that could give Orion much faster, more reliable communications during Artemis III? And how quickly could you get it ready? A couple of months ago, NASA changed the plan for the mission in a pretty big way. Instead of being the first crewed landing on the Moon, Artemis III is now planned as a test flight in low Earth orbit. The idea is to have Orion rendezvous with lunar landers being developed by SpaceX and Blue Origin, basically practicing the steps needed before an actual Moon landing. Think of it like a rehearsal mission. It's meant to prove that everything works together before they try landing astronauts on the lunar surface in later missions. On paper, that sounds straightforward, but in reality, there are still a lot of missing details. NASA hasn't really explained things like what orbit the mission will use, how long it will last, or exactly how all the pieces will come together. And now, the RFI gives us some of that answer. Orion would reportedly operate around 250 nautical miles above Earth at a 33-degree inclination, which is much closer to ISS-style operations than a high Earth orbit mission profile. The document also talks about testing rendezvous and proximity operations, basically all the complex orbital choreography required to approach another spacecraft, match trajectories, hold position nearby, and eventually dock. Those are critical capabilities for future lunar missions, and NASA seems focused on validating them thoroughly. A question is, what triggered the RFI in the first place? NASA says Orion's current communication system isn't ideal for this updated low Earth orbit mission profile. Orion was mainly designed for deep space operations using systems like NASA's Deep Space Network, but LEO creates a different challenge entirely. Communication windows change rapidly, Earth constantly interrupts line of sight, and maintaining continuous high-bandwidth coverage becomes much harder. Now, NASA wants something closer to broadband internet in orbit. The agency is asking for support for live 4K video, high-rate telemetry, large file transfers, and near-continuous connectivity during docking operations and crew activities. That strongly suggests NASA is looking at commercial satellite networks as a possible solution. The document doesn't name companies directly, but the requirements sound very similar to systems like Starlink or Amazon Project Kuiper. The performance targets are ambitious too. NASA wants Orion connected more than 75% of the time, with downlink speeds ranging from at least 12 megabits per second up to potentially 20 to 50 megabits per second. That's enough bandwidth for live 4K video streams, high-quality imagery, and large telemetry datasets. They also want uplink capability above 500 kilobits per second for commands, software updates, and data exchange. NASA appears open to two different hardware approaches. One option is an external antenna system, permanently mounted outside Orion. That would likely offer stronger performance, but it also creates major engineering headaches because the hardware has to survive launch conditions, operate without active cooling, and remain inaccessible after installation. NASA says this version would need to be delivered by fall 2026, which is an extremely aggressive timeline. The second option is a crew-deployed system that astronauts would unpack and set up once in orbit, something like a portable antenna positioned near a window. That approach would be easier to integrate and gives contractors more schedule flexibility, though it may deliver weaker performance and add operational work for the crew. NASA's target for that option is early 2027. What makes all of this technically and strategically interesting is how strongly it reflects NASA's growing dependence on commercial infrastructure. Instead of building every system internally, NASA is increasingly leaning on private companies for communications, transportation, and orbital operations. The Artemis program is becoming much more of a public-private ecosystem than a traditional government-only space program.